Hello everyone, today I will deliver a lecture on numerical solution of SDOF. SDOF means single degree of freedom. Firstly I will cover the numerical solution of single degree of freedom by Newmark-Beta method, and then numerical solution of single degree of freedom by constant average oscillation method, or which is called CAA method, and the numerical solution of single degree of freedom by linear acceleration, which is LA method. And if I will get enough time, then I will show the how to download the ground motion from uh, PR and NHR. But I have been covered another video that how to download the seismic ground motion. That's why I'm not focusing this point. I'm focusing the numerical solution single degree of freedom with Newmark-Beta method and constant average oscillation method and linear acceleration method. So let's see. So this is the numerical solution of Newmark-Beta method. So we have been seeing the Newmark-Beta method, the most widely used numerical approach for solving dynamic problem in Newmark-Beta method. Actually, it is set the solution method in different physical interpretation of different value of, and the total simulation is divided into a number of interval, usually equation of delta t, and the unknown displacement as well as velocity and displacement in solve the each instant of time. The method solving dynamic motion, which I plus 1 comma and time step resultant. So we know the static K U into F. K is stiffness and U equal to displacement equal to force. So force equal to stiffness into displacement. But in the dynamic portion, we know the sum of the part will be added, which is this is force, this is Ku. This is the dynamic portion. This is the static portion, and dynamic portion we know the damping C, and the mass will be added, and the mass will be derived from derivation from del U d square divided by del t square, and del U divided by del P will be steep damping. Okay, so let's see, we have been seeing here ME and the derivation coming from MA into CB into KU equal to F. So this is the KU in KU into F equal to static. We known in and the dynamic portion is added MA plus CU. M is a mass and A is a acceleration. C is a damping and B is a velocity. Okay. So B is derived from this equation. We can see displacement derived from this equation. So now we see this is the numerical solution of a single degree of freedom by beta method. Now we'll see the numerical solution of a single degree of freedom by constant average oscillation method, which is CA. Okay, let's see. The solution suggested by the Newmark-Beta method, the constant average oscillation method CAA method, is the most popular because the suitability of solution and the simple physical interpretation provide. Okay, that's why this solution is popular. And the method is assume acceleration to remain constant, okay, during the each small step interval delta t, and this constant is assumed to the average acceleration method into two constant instant interval t and t plus 1 term. And the CA is a special case is Newmark-Beta method, where A equal to half, which is 1 by 5, 1 by 2 equal to 0.50, and beta is 1 by 4, which is 0.25. And we have been seeing the velocity is given del t by 2, which is 5, and displacement is del t square divided by 4, which is 0.25. Okay, so we have been seeing this what I will say, this the inserting this value equation 1.55, which is 1.55. This is the main equation M, C and KU. The equation will be obtained M plus C plus del T into KU delta E, this equation. So we'll figure out we'll call this portion M effective. So how we'll get this is the M effective. Actually I'm saying X bar, but we will define this is M effective and this is C effective and this is M1. So this is C effective, we are known. We'll separate him and this is the M1. Okay, and in this way I will solving this equation. And what the major change in linear isolation method? So now see the linear numerical solution of single degree of freedom in linear isolation method. So you can see the inserting CA instead of constant average method, which is CA method, the general form of Newmark-Beta method, or other special cases it may be used to convenient the numerical formation shown before. Among the special case, the Newmark-Beta method, linear isolation method is also quite widely used. Okay, using this method is governing equation time step integration the following forms. Okay, so linear isolation method, which is A, instead of assuming the isolation constant between I th to 1 plus I tm step, assume in the constant average isolation method. The linear isolation method assume the isolation method vary linearly between each step. Okay, so this also made, and the special case is Newmark-Beta method, which is alpha is 1 divided by 2. In Newmark-Beta method also 1 divided by 2, which is 0.50. On the other hand, we can see the beta is the constant average method is alpha equal to 1 by 2, which is 0.50. And linear in the linear isolation method beta is 1 by 6. On the other hand, we have been seen the constant average method, the beta is 1 divided by 4, which is 0.5. We have been seen here 1 divided by 4, which is 5. So the in this way we have been seen the alpha is remain same, which is 1 divided by 2, but the beta is changed 1 divided by c. That's why we have been seen here 1 divided by c. In the remain same M, we are taking this is M effective and this is C effective and this is M1. So how we'll calculate this? Let's see an example. We've been seen here. All the data is given here. We are calculating MK, CT, M1, N0, which is given from L to, and M equal to minus MG, G1, F1, A1 equal N0 equal to F minus. We are taking, if we resize here, that will be MA equal to F0 CB into KU. This is the main formula we have been seen in previously. This is this formula. Okay, we are using here this formula. Just M is taking the below, and this is the M effective. If we know this is the M effective, and this is the C effective. We have been seeing this is the C effective, and we are taking M1. This is the M1. Okay, if we calculating in here, so you can see M effective, C effective and M1. So we have to calculate in here. I am deriving here. On the other hand, M is given the mass, and C is damping coefficient is given, and stiffness is given, and delta T is time interval is given. So we will calculating here. So that's why we are separating M effective, C effective and M1 effective. Okay, so let's see how we'll solve the question. Now if we put this value, then found the A1. This is not X1, we are saying the M effective, A1 and F1, KU delta U Y. Y means is C effective, and B0 and Z Z means M1 and C1, and in this way we'll found A1. So if we found this will be A1. Okay, at first we are knowing this value is given, and we will found M effective. How will get the M effective? M effective nothing but this, we use this formula, or we are just taking this part. This will be M effective. Okay, so how will get the C effective? C effective is nothing but C effective is this portion we are taking, C plus K plus delta T. So we are taking C effective, and M1 effective. How will get the M effective? M effective is this portion, not this portion, and found M effective. And we are know the interval, how many interval we want to do, plus 0 plus 1 plus 2 plus 3 plus 4. That was how many times we want to take, but we're taking 40 times. Okay, so let's see, this is the 40. Okay, this is the 2. So if we double click, okay, it is not showing here. Okay, let it done. We've been seeing 40 step. Then time interval, if we calculate the one example for dump system, single delivery system, mass is 1 is given, and stiffness K is 25 is given, damping coefficient is given 0.5, and calculate the damping response of subject to the ground motion L central using CCA method, and time interval is 0.01. So this portion is given here. Now we will calculate M effective. I have been seeing again, and now I am seeing again. M effective is this portion, M plus C plus delta T by 2 plus K plus delta T square by 4. So we are just putting this equation, M plus delta T plus T, and in this way we found the M effective. I will get the C effective. C effective is K plus delta T, C plus K plus delta T. So so C plus K plus delta T, and found the C effective. I will get the M1. M1 is this portion we have been seeing here, C plus delta T by divided by 2 plus K plus delta T divided by 4, and putting this value and name and enter, 7.0031. And now we are seeing the ith, and the time interval is given in the question 0.01. That's why we are taking 0.01, and in this way we are taking the how many times we needed, 40 and 42, 43. Edge. How will get the edge? Edge is coming from L centro ground motion. So how will get, where we have to go to this website. I am just saying click here and go to this website and enter this website, and no scaling, and okay, if you go to this website, then we will found this as the registration NZ database will open Monday. Due to some today is very I've been seeing the previous video how to download the ground motion, so please check my previous video, then found how we'll get the ground motion database. Okay, so I'm going to that part. Okay, I'm downloading this part as a previous you can see my previous video, then you will find out how will I get download this L centro ground motion. So this is the ground motion. I am copying this ground motion and putting this ground motion in this in this area and found. Okay, I'm seeing here. Okay, I'm putting all this ground motion here. You must, if you want to, you can just download the ground motion. This is not El Centro ground motion. If you download the El Centro, then that will be fine. Okay, and F1, how will get the velocity will be, first velocity is 0 and the first displacement will be 0. F1, how will get the F1? F1 is nothing but, we know F equal to ma, which is F equal to ma, which is m into a. A is a ground motion. We have been using this formula. F equal to ma, m is a minus ma. So in this way we will found this formula. Okay, sorry, I'm erasing here. So I'm deleting this because the term because the ground motion is not the ground motion is not appropriate. That's why I'm copying another ground motion, which is I am taken in previously. So I am okay, I'm inserting this. This is the El Centro ground motion I have been taken when I have downloaded. Okay, this is the El Centro ground motion, and F1, how will get the F1? F1 is nothing but minus m into a. So minus m into a, I have been seeing minus m into a is this is the a, and this is the m, and a, how will get the a is coming from this equation, or we have to, if we want to see this equation, if we subtract this, then k will be minus into k and cb will be minus into cb, and m will be divided by all of things there. In this way, minus cb into k into divided by m. Okay, I am in this way I am found m naught, which is there, m naught, and b naught is 0, and b naught is velocity is 0, and displacement is also 0. Okay, so let's see. And second step we have been seen here. The second force, we know the force m into ag. M is here 1 and g equal to f equal to ma, m in here and a equal to here. So I'm just putting this value here and found, and now we are clicking here all things and found all the value of a. Okay, now how we'll get the another a? Another a is nothing but another a is found this equation. This will be not a, and this equation will be this equation. So let's see how we'll get the a. If we see this portion is m1, and this portion is c effective is b, and this portion m effective. So we'll find a. We all the parameters will divided by this portion. That means m effective. Then we will found a1. This is the value of a1. This is the very important message to you, because we are found a plus I. So F1 minus KU plus C plus K delta. C plus K delta means C effective. We have been already found it here. And M1, how will get the M1? C plus delta 2 plus K T square into A1. So this is the M1 and into M1 is the previous data. Okay, and then divided by M effective, and we will divide it by M effective, which is I13. So M effective is I13. This is the I13. Okay, so we have been found it here and putting value here, and in this way we will calculate all the parameters. Okay, so second step B1, the velocity. How we'll get the velocity? We'll just keep this equation velocity 1, the previous velocity we have been taking, the previous velocity is 0, and a plus I plus 1 into delta t by 2, when a plus I plus 1 delta t by delta t by 2, and found this value, and in this way we will calculate all things. Okay, okay, and how will get u2? U2 use calculating by this equation. We know u plus u is the first u, which is taken 0, and bi, which is taken 0, and delta t ai plus ai into delta t square divided by 4, and found u2. Okay, so in this way we will calculate u2 and found all these things. Now we are plotting the graph, which is we are plotting. I am already formatting curve, which is time is x-axis and displacement is y-axis. We have been found this curve, and then we are drawing time versus velocity graph. This is the time versus velocity graph. Time is x-axis and velocity is y-axis, and the relative displacement, this is the relative displacement. Time is x-axis and displacement is y-axis, and found here. And I am also comparing the acceleration, which is I have been seeing here. Okay, I have been seeing here the actual acceleration is LCM2, and the relative acceleration we have been seeing here. So actual acceleration is less and the relative acceleration is more high. So this is the CAA method. So in this way we will solve another this portion is in depth, and now we'll see how we'll calculate the linear acceleration method. Okay, so all things are remain same, just value has some value has changed, which the formula has changed, which is t divided by 6 and t divided by a divided by 6, and all the remainder will be same. So let's see. At first we know that m value is given, and c value given, k value given, and delta t is also given. Now we'll calculate the m effective. How we'll calculate the m effective? So this is the m effective for linear equation, m plus c plus delta t divided by 2 plus delta t square divided by 6. So we are calling this m effective. So in this way we are calculating m effective. I will calculate c effective. C effective is nothing but remains same as it is previous, c plus k plus delta t, and putting calculating this value and found 0.75. I will get m1, m effective c plus delta t divided by 2 plus k delta t square divided by 2. That's in this way we will found the m1. Okay, so if we calculate this one, now we will calculate the I1 2 3 4 5 as it is. If you want to get more and more. This is your okay, but it is not needed. But needed is the how many interval you have taken. Okay, I have been seen here. I'm just dragging. This, this is a 40 step, and a step, how many step we will take I don't know. It is calculating 40 step only. Listen to the data is taken. Listen to I've been seen. You can download for listen to data from this year, or you can see my previous video for getting the listen to how download the listen to data. I'm just copying here and putting this here, the data of L Centro, and found here. Okay, we are taking only sorry. Okay, so all data is giving here. And F1, I will get F1. F1 is the same as it is previous, which is force into F equal to MA, which is minus MA, which is given M into A. I will get M is given is here, and A is equal to here. So in this way I found A. And A1, I will get the A1. A naught is found from this equation. We know the F naught minus K CB into K minus 1. I will get we have been seen the in the main equation of constant average solution method, which is the Newmark-Beta method, and we are taking from in this we taking here M minus K minus KB. KB is taken here, and minus CB also KB here, and divided by A. So this equation will be formed like this, and found like this. So in this way we are calculating an A1, and velocity, initial velocity is 0 and displacement also 0. Now we are calculating again M2. How will calculate? We know F equal to MA minus MA, so M into A. This cell and this cell, and we are calculating here, and clicking all the data is here, and found all the data is like this way. Now we calculate A2. How will calculate A2? A2 is complex. We'll using this portion, but it will be not X, it will be M effective, and it will be Y C effective, and it will be M1. So if we go to the acceleration linear acceleration method, this portion, then we will show this way. This will be M effective into A, and F minus KU C effective into B, and M1 into A. But we are finding A value, that's why we will taking this here to divide it by M effective, and in this way we will found here we can see here all the parameters calculating here, and found 1.99, and all the calculation will be same as it is. So velocity is given the constant, sorry, this is not constant, this is the linear acceleration method. So the velocity formula will be there, B initial, the first velocity plus A naught into delta D divided by 2, and found this, and it will be calculated the remaining. I will get U2. So you can see the U2. This is the formula of U2, which is U plus delta T by 2 A by 3 into. So remember this is A by 3, and AI plus 1 divided by C. So in this linear acceleration method, it will be A divided by 2. On the other hand, we have been seeing the acceleration constant average acceleration method. This that was not the same B plus U. So you can see here the constant average method we have used delta T divided by 4, from this equation. On the other hand, we can see the equation has changed when we have been used linear acceleration method, which is taken a divided by 3 and divided by 6 delta t square. So we are changing this equation and found here. Okay, I'm just clicking here and found all the data are coming here. So we are seeing here, this is the relative displacement versus time. This time is x-axis, and the displacement is y-axis, displacement to y-axis. How will, if you want to, so I will draw the curve. We just clicking right click and series here, edit here, and x-axis. Now we are selecting all the x-axis and y-axis, and now we are selecting all the y-axis and clicking OK and clicking OK. Then the graph is appeared here. So in the way we are plotting another graph, which is time versus relative velocity. Time is x-axis and velocity is y-axis, and found this way. And this is the acceleration, relative acceleration. We have also x-axis is time and y-axis is acceleration, and found this curve. And this is the L center in the orange color, and the blue color is a relative acceleration we have been seeing here. Okay, now I hope that you can plot this. Now I'm seeing the what is the difference between, what is the main difference of constant average acceleration method and linear acceleration method. So I know the time interval, I know the ground motion from El Centro or Kobe or someone. So we have been found acceleration velocity and displacement by acceleration method, and we have been found the displacement acceleration, displacement, and velocity and displacement by linear acceleration method. So we have been seeing here the acceleration point one in the 10th when the cell number 10, we have been seeing 10 second, 0.1 second, the acceleration when the L center acceleration 0.1975, we are seeing the relative acceleration is remain same 0.1017, and the linear acceleration remains same. So when we will go the time interval when 40 seconds, we have been seeing the L centro ground motion acceleration is found 0.1970, but we have been seeing here the H is acceleration. So 0648 and 0649. 0649 is the linear acceleration method. So 0649 is found is linear acceleration. So we can see the acceleration is faster in linear acceleration. We can see, we can check another one which is 3 seconds. Okay, we are seeing which is 0.9648, which is acceleration, but the acceleration has changed, which is 7.99 and 7.9919, but we have been seeing 7.19, which is 60. So acceleration has also changed. We must say the acceleration has also changed, but linear acceleration method is increased. So in this way we can see the velocity is 0.5038, but the velocity is lower, which is 5834. The displacement is 0.2694, but the displacement is linear acceleration 0.2096. So we can see the linear acceleration method is getting the more value than constant average velocity method. So we can I am plotting here some graph in the axes. You can see. So this is the velocity versus time velocity versus this is the velocity graph, which is dotted. The red color is linear acceleration, and the blue color is the constant average acceleration method. And this is the displacement curve I have been shown here. So displacement curve we have been seen here. The dotted line of red color is linear acceleration, and blue line is constant average acceleration. But we are seeing the linear acceleration is getting the more displacement compared to the uh, what I will say, compared to the constant average acceleration. So I just taking some notes here. This is my these are taking from my research, which is I found B, the column diameter BDL, and the axial load we have applied to 50, which is 56.2 kilonewton, M equal to 56 divided by G, which is 32.5 for 32.2, and found 1.7, and equal to constant 300 KSI found 42, which is converted cube per feet, and a momentum inertia BD cube by 12, and found 433 inches square, and we take converted into feet per feet to the power 4, and CAC 12 pi by L cube, and found 1252 cube per feet, and the constant damping ratio is 5, MC equal to 25 root over km, found 4367. If we put this value on what will be happen, now we'll see. If we put this value in constant average acceleration, I'm just coming I'm just taking here. So what major change? So m we are saying the m will be so m will be 1.75, so 1.75. so the m effective has changed, and all the other parameter has also changed. C we have been found C 4.67, and K effective we have been found, which is 1252, 1252.19. Okay, the remain will be changed. So we are taking my real exam, real experiment, and putting this data. I'm just changing the M, C, K, delta T will be same. Then all the other parameters will be same, as we are using LSM2. If you change the ground motion, then the data will be changed. So what is the changes? We can see the all the parameter have changes. The relative displacement has changes, and the relative velocity has also changes. The acceleration also changes. We can see the maximum acceleration. The LSM2 has found 10 feet per second square, but the relative displacement we have been found 25. So these are the more and more jump, the more data have been found. So if we use this again on the linear acceleration method, so I'm just putting here. So what measure will be changed? I'm just taking a snap that I will show how many data have changed. We are seeing here at first the acceleration we are setting the L-center acceleration is 10 feet, and the relative displacement have found which is 12. But if we input this parameter, then all the other parameter will be changed, I think. So I'm just putting this value, which is m is 1.75, and C equal to have been found 4.67. okay, 4.67, 7 and K equal to have found how much 12 1252.19. Okay, so we've been seeing all the data has been changed. So we are seeing the major change is here, as I am taking the snap here. I'm just pasting here again. So this was the previous data, which we have been seeing the relative displacement was 12, but when we are inputting the real my real what else my real scenario or real data, then we have been seeing the relative displacement of my real structure has changed. It is goes to the about to the 25. So we can conclude that all the data will be changed when we will change this parameter. I hope that you can understand. If you have any question, then let me know. I will try to clarify. Um, I will try to clarify. I hope that you can understand. If you need any kind of Excel, this Excel and that Excel, you just comment or message me, knock me. I will try to give you the Excel data. Thank you everyone. If you have any question, let me know. These are the that was my lecture. I have been seeing the numerical solution. The lecture was numerical solution of single degree of freedom. At first I am clarifying the numerical solution of single degree freedom by Newmark-Beta method. Beta method is using the constant average acceleration method and linear acceleration method. We have been seeing the linear acceleration method is getting the more value more value than the constant average acceleration method. Okay, and you can download the seismic ground motion, or you can see my previous video for how you get the download, or go to the this website and found. Okay, thank you everyone. Thank you.